Hi, my name is Mohit. Um, Today, I'm going to cover multiple things. I'm going to go over the objective of the analysis that I performed. I'll briefly introduce the solution architecture of the solution that I developed. Then I'll go over the details into the AI algorithm, the modeling process, as well as some of the initial results. And then I'll cover some of the next steps and things that might be interesting to look at. Finally, I'll give a very quick brief demo of the dashboard that was developed. So the objective of the analysis that I'm doing is to look at the social media data, especially Reddit, to extract insights such as demographics, co-occurring opioids, as well as other events, as well as other sort of conditions and medical drugs that are linked to opioids usage. So that is the primary aspect of the analysis that I performed. The reason I chose Reddit is because Reddit can help you really profile a view from an author perspective, because a large number of users make a large number of posts, and you can actually track those posts over a period of time, and it helps you sort of build at a vague level sort of a longitudinal view of the patients, of the people who are making the posts. The second sort of secondary objective of the solution that I developed was that the solution should be scalable, and it should support large data volumes as sort of so right now I'm looking at Reddit as a POC, but going forward, if we want to include other data components, it should be easy to ingest other data volumes and build more and interesting algorithms and processes. In terms of the data sets that we are using multiple levels of data sets. Some data sets are used for prediction, some data sets are used for model training. I'll go over those details in the next few slides. But in terms of the prediction, what I mean by prediction is that actual data which we're using to extract insights we're using two subreddits, opioids subreddit as well as opioids recovery subreddit. In total, we are extracting roughly 3.16 million comments from opioids subreddit and roughly 340,000 comments from the opioids recovery subreddit. And these are the number of distinct users that you can see on the screen for each sort of respective subreddit. In terms of the high-level solution architecture, the solution is deployed on a cloud-based solution. There are multiple levels to it. There is a data ingestion layer where we can ingest the data from external sources through APIs, batch, other means possible. The data lands we have a data lake solution in sort of the landing zone where we do some data cleaning, data prep, and then the data becomes ready for the model development. The key component of a system is a modeling layer where we develop machine learning models and they're deployed as containers on the cloud platform. And then we actually create a model registry which lists all the different models that we have developed, and it maps to which model we're using for which data set. So for instance, suppose that to detect pregnancy, we are using a certain set of models. To detect whether this person is suffering from depression, we are using a different set of models. So all those models are stored in the model registry. Once we have the models and we can schedule when the predictions would be run, the models would take the source data on which the predictions have to be made, and will make the predictions and push the data back in the prediction repository. And that is sort of the third layer where we say data lake storage predictions. Once we have the data ready, then that data can be consumed through any means possible. So the purpose of my analysis is really to get that analysis ready data there. And once it's there, we can consume it using SQL, R, dashboards, or however we want to consume it. And again, the key thing is that it's cloud-based, developed on AWS, and it can ingest large volumes of data. It scales with increasing data volume. In terms of the details of the actual machine learning models that we've developed. So we use transfer learning. So just to give you a high-level overview of transfer learning. So over the last 2 years, the predictive accuracy of natural language processing has increased quite a lot. And that was because of some of the innovations that were done in transfer learning. It started by Google. Now a lot of other companies and a lot of universities are also working on it. So the idea about transfer learning is that you train a model on a predefined non-domain specific data set, let's say that you have a large corpus of data available in Wikipedia, in semantic health, as well as other NLP data sets that are made available for healthcare. Once you train model on those, so you build a predefined model, and then you add a customization layer where you customize that model for a specific problem. One of the big issues in the NLP is to really get the domain specific data. So if you really pre-train a model on a large corpus of data, and the model can sort of figure out the intricacies of the language itself, and then you have a small domain specific data set, and you customize your model on that, then you get very high predictions, very accurate predictions. So this sort of transfer learning has been successfully used to achieve state-of-the-art results for complex tasks, such as Stanford question answering data set. So to describe the problem, Stanford has a data set, have made data set public, where there are questions and answers from Wikipedia, and this sort of became the benchmark data set where transfer learning and some of the models have been able to achieve better predictive accuracy than the humans themselves. So the key question is, how do we apply this concept in the models that I have developed, and I will go over it step by step. So again, just to go back, there are multiple steps. The first step is that we start with the pre-trained model. The second is the customization. I'll go over, and then we have the output. So I'll go over all of these steps one by one. So the first step is the pre-trained models. So there are a large number of pre-trained models that are available. It takes a large amount of time to train those pre-trained models. So we start that as a base so that we don't have to train them. One of the pre-trained models is BERT. The BERT is trained on the database of Wikipedia, roughly 3 billion words. It uses the transformation architecture, and the algorithm is that the way this model is trained is that it will look at a sentence, and a certain word would be sort of masked, and the model would try to predict that word. And based on that, it sort of learns the language itself. The second model pre-trained model that I looked at was ExcelNet. It has much bigger corpus, but it's similar to BERT, but it sort of randomizes the inputs of a sentence. And the third model that I evaluated, and so some of the results from SkiBERT are not yet production and not there in the model, but the third model that I looked at was SkiBERT. SkiBERT is actually trained on the medical data itself. So the algorithm is same as BERT, but the underlying data on which that algorithm is run is medical data. So that is more domain specific data in this case. So again, this maps to the first step, where we are starting with a pre-trained model, and we use the pre-trained models that are already there, and we start with the next step, which is the model customization. Now, for model customization, we have to map it to the specific domain that we are trying to map it to. So suppose we want to look at the data to extract gender or depression. So suppose we want to look at a pre-trained model, and we want to customize it to identify whether a certain piece of text, a certain comments represents whether the person is suffering from depression or not. Now, how do we do that? We need domain-specific data. So in this case, to get the domain-specific data, I thought the best resource to get the domain-specific data is also Reddit. So if I look at Reddit, there are communities for depression and Ask subreddit and other things. So the way I do it is that I look at all the comments, all the posts that are made in the depression subreddit, and I make an assumption that all those posts are from users who have depression, and then I need sort of a placebo or other class which indicates non-depression, and I look at Ask Reddit subreddits where people are posting a lot of comments, and I classify that as non-depression. So I have sort of two classes here. One is depression, which maps to all the data that is in the depression subreddit. And then we have the sort of the non-depression class, which is ask all the comments and that are posted in the Ask Reddit subreddits. So then it becomes a classification problem. And I use this data to then customize the pre-trained model that we had created, that we had used, BERT, ExcelNet, and SkiBERT, to build a classification model to see whether a certain piece of text represents whether the user is suffering from depression or not. The advantage of this technique, let's say, over other techniques such as regular expressions, would be that if you're doing regular expressions to extract things like depression, pregnancy, gender, and ADHD, it would be we can only look at so many patterns. But when people sort of express the opinion, they use a large set of different patterns, and if we use sort of machine learning, the machine can pick up different set of patterns that we may not have thought about. So this sort of gives the details regarding the data that we're using and the models that we're implementing. Similarly, so gender depression. Similarly, for ADHD, I follow the similar process that I look at ADHD subreddits and see whether the comments that are extracted from ADHD assume that they represent ADHD and so on and so forth. And the default in this case is again Ask Reddit subreddits. For adverse events, when not-me test conducted, so there's a pre-annotated NCBI data set that is available that I use to customize the model. So for pregnancy, we are looking at multiple subreddits to identify whether somebody is pregnant. We're looking at the pregnant subreddit, but there's also baby bumps subreddit, which I thought had much more data in it. So we're using both those subreddits to identify pregnant users and Ask Reddit as the default. And then again, we build a classification model. And this step 2 maps to what we see step 2 here in terms of the model customization stage. Once we have it, we fine tune it, we evaluate different models, and we come up with the accurate, and we see how the model performs. So what I've found was that so these results are averaged over multiple test data sets. For things like depression, ADHD, adverse events, and sort of pregnancy, the model works really well on the training data. And we see the very high accuracy metrics across precision recall and F1 score. For gender, the accuracy becomes slightly less, and that sort of makes intuitive sense as well, because if you're looking at, let's say, the language that is used between depression and non-depression, the language would be very different, and it would be easier for machine to pick up that difference as compared to gender, because that sort of becomes very subjective. So these are the other modeling details. The other things that I did. One of the big issues when looking at Reddit is that we get a lot of data that is not relevant. A lot of comments are not relevant to. So even if I'm looking at the opioids subreddits, a lot of the comments are not relevant to the are not linked to the opioids usage. So and again, one of the big challenges, at least, was that how do we know whether it's relevant or not? How do we either we go on and start annotating the data? That sort of becomes a challenge to do that at a scale. So I looked at what publicly available data sets are available to use that to annotate some of the comments. So I found that there's a text annotated DBpedia that is crowdsourced and publicly available. It's open source, and what it does is that it looks at the Wikipedia articles and it tries to annotate those articles and extract what are the key entities that are described in those articles. And I use that to apply to all the comments that we receive from that we receive from the opioids and opioids recovery subreddit, as well as the subreddits that we're looking at. And if you see these two examples, you would see the difference. So both the comments were posted in the opioids subreddit. If I'm looking at the first one, if I look at the entities that are extracted, they are really relevant to opioids. They talk about body parts, opioids that people are taking, and so on and so forth. But if you look at the comment below, it's a comment by somebody which is not relevant to anything, which is not linked to opioids. So there's no point for us to run any analysis on the comment below, because it will just create extra noise. So, and we extract the entities, we see that all the entities that are extracted are really not linked to opioids. So we remove that comment from the purpose of our analysis. So that's what sort of we do in terms of filtering our content. Finally, I'll go over the next steps, and I think some of the things that I learned while I was working on this POC. One thing that is really helpful, especially for tasks where we are trying to predict sort of rare events, is that we tend to get false positives. So even though the accuracy was really high on the training set, but when I applied it on the opioids, I could see that we are getting false positives. So I think in those cases, sort of in the workflow of the whole process, I think it's very important to have a human review process where humans can review some of those results and update them and push it back into the model itself. So right now I don't have it, but that is something that would be really interesting to build if this is pursued further. Other thing that was a challenge working with the social media data is that social media data contains a lot of noise. Even if we use annotation and things, we get a lot of noise in the data. So, but if we were to apply the same techniques that we are applying, transfer learning to data sets where the noise would be much less, such as the clinical notes. And I looked at some of the clinical notes, and so then there we would be able to extract much better accuracy and extract much more relevant variables such as social determinants of health like income and education and other information that is really contained in the clinical notes in the EHR systems. Um, Finally, other thing to look at would be to really automate the whole process end to end from text annotation to model development and deployment. Part of it is being done right now, but really sort of build further upon it. So those are some of the things to sort of look at into the future. So with that, I will now give a brief demo, and the demo consists of two components. So I'll stop sharing my screen so that I can share the other screen there. Okay. I'll share. So I'm going to so again I'm going to really give a brief overview of some of the data that I created and a sample dashboard that was developed. Again, the objective of the analysis was really to come up with sort of a detailed data. Um, so this is a subset of the data and some of the tables that were extracted and some of the views that were created. And again, the idea is that if somebody wants to use it, these views can be made available in a SQL format that people can use it. So essentially, I'll give a sample overview here of three views. One view is that we have an AE level view. So here, let's start. We start with this. So we have the opioids taken. So we have the author. So who is the author of the comment? We have some information about the full name as I described. This was the comment, and we are extracting all the opioids that those users took. So to identify which opioids we are extracting, I looked at the website of Health Canada, and I looked at all the drugs that Health Canada identifies as opioids, and those are used as to identify the opioids in the text. The other data that we have is this is sort of an author level view. Again, this is a subset here, and here the idea here is that instead of looking at the view for each message, we can look at author level. So this identifies whether the author was ever pregnant in all the data that we have, and whether the author ever suffered from depression and or had ADHD. If we were to go in the message level view, so this is the message level view. Here we look at each post in itself and whether we see whether the post indicates pregnancy or not, depression or not, ADHD or not, and we have a date time attached to it. So when that message was actually posted, and then sort of we can use it to build a longitudinal view if we want to. The next thing I'm going to share is a simple dashboard that I've developed just to illustrate some of the things that are possible. And my apologies for the bad visual here. I got into some technical challenges this morning, so I have to log into this virtual machine to show it. This was actually running on a server, but I had some last minute technical issues. So I'm going to briefly give you some of the things that we see here. So this view is at a user level. So what this shows is that whether the users ever were ever pregnant, whether whether they ever had ADHD, whether they ever had depression. And this data is running on a subset of the data of the large data set. So we have 11.5 thousand users, 268 users are identified as that had pregnancy, 1979 with depression, and 996 had ADHD. So if you look at, so here what we can see is the other co-occurring opioids. If I were to choose at any of the opioids here. So again, so sometimes people say oxy, sometimes they say oxycodone, so maybe they are the same things. So suppose I look at oxy. So people, when they take oxy, they also take these opioids, and we see how much, like, so this tells us that if somebody is taking oxy, what are some of the other opioids they are taking, and we can filter it by ADHD, depression, and pregnancy in this case. And then we also sort of list the adverse events that are associated with those users. So if I'm looking at, let's say, so all the users that we have, for that in all the posts that they make, what are some of the adverse events that they mention that are associated with, let's say, taking of oxy in this case. So this sort of gives a user level view. And again, we have the entire data set ready, and anybody can do their own custom analysis and build their own views. This is just to give to do an illustration. The second sort of view I wanted to show you, this is a static view, and this is just a static view, and just to illustrate some of the things, essentially, this sort of shows the word cloud, and this sort of describes the things that people are talking about. And I look at three classes. So if I look at ADHD, depression, and pregnancy as three different classes, and it's a comparative cloud, that what words people are using in one sort of a context as compared to the other. So if I look at here, if you look at, let's say, ADHD, and when I looked at it, I looked at Adderall, and I found that Adderall is widely used for ADHD. So we can see that what are some of the things people are talking about when they're talking about some of these things. So if you look at pregnancy, baby, and these things have a higher sort of frequency, and so on and so forth. And here, these are the total number of posts in this subset of the visual that I have, 86,000 posts, and we have all these details. And this sort of visual shows of all the users that are pregnant, how many also suffer from depression and ADHD. So of all the users that are pregnant, we see that 72 suffer from depression. So that's and it's only in the opioids subreddit, and roughly 55 out of 341 also suffer from ADHD. So again, this was just to illustrate, like, at a high level, what some of the visuals that can be possible. But anybody can do their own custom analysis as well. So that's all from my side.